Hello and welcome to Hiperativa Wildfire. Seasons are longer, hotter and more expensive, but smarter forests can change the outcome. Drones, sensors and data now give rural communities minutes of advantage when minutes decide everything. Today, you'll see how low-cost cameras, thermal drones, AI detection and smart maintenance work together to prevent fires, catch ignitions fast and keep crews safer. Start with eyes in the forest. Fixed cameras on tall ridgelines scan 24/7 for smoke columns. Modern systems use AI to compare live video against yesterday's background, flagging the thin vertical plumes that humans miss at long range. Pan-tilt zoom heads track a plume automatically and triangulate with a second tower to estimate coordinates. Add infrared to see through haze and at night. These alerts go straight to dispatch with a confidence score and a map link. In many pilots, AI cuts detection time from hours to minutes. Now, add drones. After a lightning storm, small quadcopters fly preset grids over high-risk ridges. Thermal cameras spot residual heat in stumps and strike points that can flare later. Fixed-wing drones survey vast canyons with long endurance, building daily orthomosaics for fuel mapping. During an incident, a simple rule of thumb keeps everyone safer. One drone at 120 meters AGL with IR can give incident commanders a live perimeter, find spot fires across the line, and guide crews to safe anchor points. If aviation is restricted, tethered drones rise from a truck to provide persistent overwatch, powered from the ground. Sensors make the forest talk. LoRa WAN weather nodes scatter across ridges and valleys, measuring wind, humidity, and fuel moisture. When the fine, dead fuel moisture dips below critical thresholds, the dashboard flips from green to amber to red. Heat and smoke sensors along utility corridors flag anomalies before a small fault becomes a big ignition. Soil probes in reforested slopes track moisture recovery so crews know where to mulch and where to irrigate after a burn. All of this feeds a risk map that updates every 10 minutes. Maintenance becomes targeted and cheaper. Instead of clearing every mile of line, utilities use LiDAR scans and AI to rank spans by risk: tree species, lean angle, wind exposure, and historic faults. Vegetation crews then hit the red zones first. In wildland-urban interface neighborhoods, smart cameras and acoustic sensors watch illegal fireworks and off-season burns, generating a gentle warning to the homeowner and, if needed, a call to local fire prevention officers. Roadside weather nodes trigger dynamic "no parking in dry grass" signs on red flag days. Data fusion is the multiplier. A cloud map layers satellite hotspots, camera detections, drone IR, wind, humidity, and fuel moisture. The model projects where embers will land in the next 30 minutes given current wind gusts and slope. Command can pre-position crews and engines along likely escape routes and notify ranchers to move stock from a predicted impact corridor. For communities, a simple phone alert shows a live perimeter, wind arrow, and a clear instruction: pack, stage, or evacuate now by this road only. Power and connectivity matter in remote forests. Solar battery kits with small panels and LiFePO4 packs keep cameras, sensors, and LoRa gateways alive through smoke and clouds. Starlink or microwave backhaul links remote towers to county dispatch. If backhaul fails, gateways store hours of data and forward when a repeater comes online. Rugged enclosures, lightning arresters, and wildlife-proof conduit keep systems running through seasons. Cost is coming down. A pilot kit for one ridge, 2 PTZ cameras with IR, a LoRa gateway, 5 weather nodes, and a small solar battery pack can slot under the cost of one helicopter day. Add a thermal drone kit and you have a 24/7 detection layer plus rapid verification. Grants from state forestry departments, USDA, and utilities often cover pilots when communities bring sites, volunteers, and a maintenance plan. What about privacy and policy? Aim fixed cameras at forest and utility corridors, not backyards. Post signage for monitored areas. Publish a simple data policy. What's captured, how long it's stored, and who can access it. Coordinate with the local fire chief and the state forestry office. For drones, operate under Part 107, file COAs when needed for public agencies, and coordinate airspace with incident command on fires. A playbook for getting started looks like this. Pick 3 ridgelines with clear views of historic ignition zones. Secure power and connectivity with solar battery and a satellite or microwave link. Install 2 PTZ cameras with overlapping views and a LoRa gateway. Place weather nodes along slope aspects that dry fastest. Train volunteers to verify alerts and launch a thermal drone within 10 minutes of a camera ping. Run monthly drills with dispatch. After the first season, expand along the corridors that produced the most alerts. Bottom line, smarter forests blend cameras, drones, sensors, and simple models so small ignitions stay small. Detection in minutes, targeted maintenance, and clear public alerts save acres, homes, and lives. And they cost less than fighting the big fires we fail to prevent. If your county has hills, wind, and dry fuel, you can start this now with off-the-shelf tools and a solid plan. If you enjoyed the video, drop a like and subscribe to Hiperativa Tech for more tech like this. Cheers!